will talk about reliability, another important area in cloud data center, and the outline for today will be our first start with some of the cloud computing applications, and then I will introduce also hybrid cloud and the issue of resource provisioning. I don't think I have any slide on security, but I am happy to talk about it if there is interest. But we will talk about reliability. I always define reliability as both security and fault tolerance, and addressing reliability problems for hybrid cloud computing. And I will also talk about trust management, some performance results, and we will conclude with some issues here. Now, one of the applications is smart living of the application of cloud is, as you can see, that we have smart cities. The idea of smart cities, smart things, is going big. So we can actually link, nowadays we have sensors and other resources that will allow us to collect information and also exchange information. You can see buildings, airports, trains, vehicles, all these can be interconnected and help individuals to monitor what's going in there, as well as know what's going in a given area. For example, we can actually take this as a closed area. You can look at this where the professors live in JNU here. They are surrounded by walls, actually, so they feel safe. I was talking to Professor Zahir. We can achieve that really now without walls, right? If we actually have sensors and other necessary technologies. This is what is now. In Australia, we don't have fences. We just your house is just open space. But everybody has the mobile phones, and you have cameras on your house. This camera talks to the sensor and talks to the mobile phone anytime, anywhere. You can check what is in your fridge, and if there is no enough food in your fridge, you can actually buy on your way back from work. If anything, even if the dog comes into your house, around your house, you can see on your mobile phone. And the camera is also very good at night, daytime, anytime. So you can go at night out with your friends. You can still see what's happening in your house. You can track everything. So technology is changing the idea of this fortress living environment. So people will live together, but they can also monitor what's happening in their house. Social networks. Now, a lot of applications of social networks. Again, social network, the backbone of social network is cloud computing. Without cloud computing, social network will not exist. So a lot of applications, sociologists use data from social network to study social structures. Health people use for understanding how infections spread quickly. Business people use for advertising and also for sentiment analysis and things like this. Criminologists also use the data to identify frauds and sometimes to find the leader of a ring. And so, again, as you can see, social network data is based in really cloud computing environment. Smart agriculture, this is actually, it is close to my heart. I was trying to convince these guys to apply for grants with me around this smart application of cloud and smart mobile phone and mobile technologies together to bring to really enhance agriculture. And I tried with Professor DP at some time to talk about this, to push, but I will push again and again until I can convince him. But this comes close to me because I'm very much interested. My main background is actually from agricultural society. I want to see this technology applied in agriculture, particularly from where I came from, if I get an opportunity to do that. I'll talk about agriculture shortly in detail. So there is a lot of scope in agriculture. You see, we want to translate. My idea is I can come up with a lot of solutions, but I want to translate it to something that community will use it. So moving from theoretical into practical application. Internet of Things is an area that's very hot, but if you look at it, cloud computing serves as a background. We have a lot of problems with Internet of Things yet, but this is another very, very hot area that many people are working in, and it's changing the scope of cloud computing. Cloud computing is not only used for processing and storage anymore. It's coupled with Internet of Things. The application of Internet of Things changes the scope of the cloud computing completely. So there are security issues here. Now, when you look at cloud computing, one of the things I was trying to do for you to understand is you're looking at cloud computing as 10 servers. Fine, start from there. But now look at it as 1 million servers. So if you have 1 million servers, or look at it from users' perspective, you have 1 million users at the same time. How do you manage the resources? How do you make these users happy? 1 million users in few minutes. So what I'm trying to say is make it multiplied by 10, 20, 30 millions. But if you actually just look at people who are using their mobile phone or checking their email on mobile phone, just in India, if you say in 1 minute 100 million people check or send tweet data, all that Twitter data goes to data center first, which is cloud computing. 1 million people. It's not actually three people are using cloud. So when you think about cloud, think big, think in scales. Something that you're not actually solving a problem of simple thing, putting juggles together. It is a big thing, it's a big problem. But the idea is we use divide and conquer. We know that it is millions of resources, but can we divide it? Small, and conquer. So you don't also want to look at this big picture and say, I will do it in 1 day or in 3 years of PhD. No. Anything you do it first, small, then go in scales. But IoT brings a lot of security issues, a lot. I can talk all day if you want to about IoT and its security. Now, the agriculture is one of my ideas is really to increase or to improve livestock monitoring, disease forecasting systems. This is one of the problems we have, particularly in developing countries. Okay, so now most of these farmers have access to mobile phone. By actually now coupling it with what is now came to be known as fog computing, mobile phone, fog computing, and cloud computing, we could actually bring veterinary from where the clinic in the city to the villages and towns to improve and manage the livestock there. So moving all these animal husbandry things that in many developing countries they still use the conventional, the traditional way of managing this. We can actually use this technology to improve the livestock management there, the diseases, okay, the foods. So if we could really do this, we solve a lot of problems. We improve the life of the people in the village, which are actually the backbone of any country. They produce the food, they do a lot of hard work. Okay, so we can also come up with something, we improve also food security. So this is why it is really close to my heart that I always wanted to do this, but never got an opportunity to do this. I am interested also in application of this cloud computing technology in improving the sustainability, efficiency, and quality of the soil, of the land, of the resources that farmers use. So they need to do it in a sustainable manner. All this information, all this research, worldwide they're doing research about sustainability, about soil improvement, about farming. All this information is available, but it is how to exploit it and how to actually present it to the farmers who may be educated or uneducated, but in a way that they can understand. So instead of actually keeping the information here, we can take the information to them. So my whole idea is take the health to them, not actually health, they come to the health. Take the agriculture to them. They already have millions of years of expertise, but now you're actually telling them this way of you, the way you're doing is very hard way. So the crops can yield more if you do it this way. And instead of using this pesticide to actually destroy the soil, you can actually control these things. So these are the ideas that we need to take the cloud computing now as it matures. It is now time to actually use it in an unconventional way that is used. And one of the most important thing is taking the market to the farmers, not farming to market. So all of the things I'm saying now is I'm actually turning things upside down. This is what innovation is. When you try to innovate something, you don't actually follow what the crowd. You change. You try to come up with something new. Can we do something like this? So how can we improve the life of the farmers, the livestock, using the technology of cloud computing, mobile technology, and all this? Okay? Now, I can keep talking about this because I'm very much interested in this. I actually think sometimes about taking the before this base station that you see for mobile phones everywhere. I actually developed a system that takes a bus. You know, the bus that passes through the village, that goes from one city to the another city. It acts actually as a wireless network, as a base. As the bus comes in, your mobile will download data on the mobile, on the bus. And the bus will carry data from the city to you. anything. Say, for example, if you are interested about health. So the bus, I call it library. So the bus has information, not only carrying people, but also carries information from the city, from the internet. It stores a lot of data. You send a query, and when the bus passes by the city, by the village, all this data, all these answers to your queries is downloaded in the server in the village. So that way, you don't really need this infrastructure that you need to build, internet and wiring and all this. So it's basically in ad hoc wireless concept of that. So there are many things that we can do to improve this, to use cloud applications. So again, as you can see, a lot of gadgets here. And the idea now is bring cloud to the people, bring the hospital to the people, not people to the hospital. Okay, there are things, many of the things. See, if you look at the hospital, the way the hospital is structured is some of the people will go for little things to the hospital, which actually they can get the information or medication where they are. Right? So that will free a lot of hospital places to the needy people. The idea of bringing hospital to the people or clinics to the people is this. There are a lot of information available there. So whole idea is to see, so now we're using actually to determine if somebody has a cancer. We want to determine the survival rate after this person is treated. We wanted to determine using cloud computing technology and prediction algorithms to find out how long this particular person will survive. We are not playing God here. Okay, what we are saying is basically there is data that shows some people survive 5 years, some people survive 10 years, some people survive 15 years. But what we're trying to do is these people should have quality of life, improved quality of life within, if they have 5 years. How can actually we know the quality of life for them to be improved? That is what we're trying to do here. Again, very interesting issue. The idea of taking the hospital to the people is, what we're saying is that there are a lot of gadgets, lots of them. So instead of keeping patients here, there are numerous cases, numerous number of situations where people can be treated at home, very cheap, instead of being treated inside the hospital. So this is another application of cloud computing where we actually couple IoT with cloud computing environment. Any question? I'm still talking about application of cloud computing. They are numerous, but I just picked up some that we can see. Now, these are some of the applications, real applications used in cloud computing environment. So, what I have said so far is cloud is now very important. The same way you can't live without your phone. See, I am good. I can leave my phone in my room. I came without my phone. But many people can't. The first thing when they wake up, they can see is the phone. Right? I have seen girls actually saying, "Good night, I'm sleeping." Right? So but what I'm saying is now cloud has become the same thing. Without cloud, none of these things. That girl could not say I'm sleeping because the cloud is down. To make them happy, what do we have to do? The cloud have to be reliable, always available, right? Because the girl sleeps midnight or 1 o'clock or 8 o'clock, we need to make sure that that girl will say goodbye and sleep. Otherwise, she won't sleep. Reliability of cloud is now becoming very important. See, this is practical issue. It's not actually a joke, right? That is what the lecture of today is. How to make these young people happy. Otherwise, you see the way students protest out there? If I am a vice chancellor, I would be actually happy to talk to them. Solve this problem, because that is what reliability means. Right? So if they say your cloud computing is shit, it doesn't work, reliability is not there, I lose customers. Right? So one of the most important quality of service or service level agreement that users make, whether knowingly or unknowingly, is the availability of the system, the cloud computing, anytime, anywhere. If I am on the plane, nowadays if you go on, what they call them, some planes, they said free Wi-Fi for you. So all this, whether you are flying on the sky, on the land, on the in the sea, you want to use it. So because some of the applications that I just showed you are very, very important for health, right? Sometimes we are, doctors use cloud technology while they're operating. Any wrong information or unavailability, very disastrous for the health of the patient being operated. So these are the motivations for the cloud reliability issues. Okay, so I'm not quite sure. Sometimes you may experience system down, or you can't send Twitter. Yes, many of you angry about the government. It's not the government that stopped the message from going. Is the cloud is down actually. So there are two different ways that the system can go down. One is planned, because we are doing maintenance. We are installing something. See, we do this regularly, regular maintenance is there. We know about it, right? We make plans for backup systems are there while we are maintaining this system. And the other one is unplanned failure of the system, which we are going to focus on. Okay? So the other one is planned. We know about it. Probably sometimes you get email from the university system saying that the system will be down for 2 hours, 3 hours, we are doing something. So you are okay, you already know. But what we are dealing with now is when you don't know. Okay? Okay. Now, instead of saying, any questions? I decided to put this up. Do you have any questions?
So can you tell us a bit more about that patient monitoring system, the health monitoring?
Say about what?
The patient health monitoring system that is on the slide, the previous one.
Where?
Before this slide. Yeah, this one.
Okay. Yes. Okay, this is not part of the lecture. This is something I gave last year, a keynote on connecting them. Okay, so here is what you're asking. This is cloud data center, and this is a patient, a lot of sensors, okay? And this is what we call personal server, mobile phone, and this is healthcare providers. Okay, so the cloud will be storing a lot of data, including the e-health, and it will also do analytics on the data. And this basically serves collecting data from the patient. You can collect the data by pooling it, which means the doctor wants to find out some specific thing about this patient. Okay? But the standard one is pushing, so every few seconds the sensor will collect data and push it to the data center, where the data gets stored and then processed. So the pool is when the doctor or somebody wants to find out more information, it will send a command. If you remember yesterday, I said now we use sensors to process tasks as a task. Before it's simply data collection entity. Now we actually ask them to also do some tasks. So that is what is called pull. You're pulling the sensor to tell the sensor execute this task. So this is what covers the sensor network, the big data, and health applications. There is another, these all are what we did. There is another here. See this, we actually monitor patient. We're using sensors instead of sitting in the hospital. This patient can be home, but we can actually collect a lot of information about this patient. Okay? This is also finding a patient movement. Is this, you see there are sensors on this patient. We can actually detect whether this patient is going to fail. In particular, this is what we wanted to do. You see, this is failed. This is what we mean, take the hospital to the patient, not the patient to the hospital. So you can see, we can actually know from the way this person carries the stick. Maybe let me see. No, okay. What we do is actually, you see, when if the person is sitting, when the person wants to wake up, you can measure the angle of the stick this patient uses and find out if it's improper, and then stop him from walking, otherwise he will fail or she will fail. So this is one application of, even when a person is walking, how can we measure from, you see, the speed of walking, the legs, the patterns of movement may be changing. If the pattern of the leg, lifting the leg and putting down changes, you can actually predict if this person is going to fail or no. So these are the kind of things we do in health environment. But this lecture is not about this. Just wanted to show the application. Any other question? This is not the last slide. This is just the middle, question in the middle, because I want to change.
In general, for sir, any health cloud, what we do is, the past record is compared with the present data. But that may have some aberrations. The person may be very sick in the past, but now he is doing well, he or she is doing well, and the problem may recur. So that difference may be calculated. But let's say if the person is normal, and in that case, actually, I really don't understand actually how to find that difference. That the data is getting improper and a problem is there.
A person who's sick gets well.
And again, the problem may recur. It may not be at the very high level. It may be, the beginning of the problem. So how to detect those aberrations?
Now, Dr. Zahir is putting me back to healthcare. The talk is about cloud computing reliability. We have patient who is sick, get well, but this problem can reoccur. So let us take a simple example as a cancer, right? Cancer, sometimes you get cured, but it reoccurs, right? So the reason I use cancer is because one of my PhD is also working in this area on reoccurrence of this guy called Tahsin. He's working on breast cancer recurrence prediction. So basically, what we do is that there are a number of statistical models that you can use to, if a woman has a cancer, breast cancer, and this, either there are a couple of things you do. You remove the breast, or if it is early detected, you basically through medication, hopefully that lady will be fine. But there is certain chances from the historical data analysis and from the recent advances in gene technology, gene analytics, and DNA or whatever analytics, we know that there are certain percentage or in certain type of people who will have recurrence of this thing. So based on that information, you can actually predict if this person will get with the cancer will recur or no. So it is advancement of medicine and advancement in gene analytics and also a lot of data availability. So what this big data concept brought is that we can actually have data about Indian woman in India with breast cancer, with family relationship of breast cancers, the same in US, the same in Ethiopia, the same in Somalia, the same in Iraq or Yemen. So you can actually now look at, if you filter out, there are factors sometimes that economic factor, what you call some factors, environmental factors also play games in here. But if you take at the end of the day, they are the reoccurrence of this cancer has some commonalities between these women. So we can exploit that and come up, predict, saying this person will have 50% chance of recurrence, 0% of chance recurrence. Some people will never have recurrence, but we want to predict it based on a lot of data that's available to you. As of common cold, it occurs, we know that, right? Doesn't matter that, right? So if you look at common cold, that's why they called it common cold, right? So my friend's son has cold. He is probably going to get cold. And his wife is going to get cold because it is common. Right? We don't waste time to determine reoccurrence. But this is very important. So the reason we're doing this research is we want to actually give this girl, this lady, quality of life. If we know that it's reoccurring, we want to give her medication as quickly as possible to so ensure that this this matter will be resolved. Cancer quickly discovered is treatable. Cancer that actually progressed is very bad. So the prediction is actually we want to find out if this person is going to get again. We want to actually say to the doctors, here is the data, here is what you need to treat. Okay?
So basically it's not the only individual's data, but the other society data also can be used. So that's actually very interesting.
Yeah, you have to use it, right? You have, in fact, I asked Shadat to do something like this because this we are dealing with precision. So if you have a lot of common patterns of this information, the prediction you do, the precision of your prediction will increase. If you just do it on individual basis, that somebody asked me yesterday about population. What does it mean? Population is the number of the patients you have. The larger the number of similar patients of this particular disease, which I hate it, is the better your precision is, the more the quality of this person's life will improve. But if you're using 2, 3, it's okay, but the prediction is not really high quality. So that's why when we did one of the slides, you asked me was where we linked the patient on that. So that is actually a patient who was treated. That patient has a stroke. It's a real system. The patient has a stroke, but the patient has recovered. So keeping him in hospital is useless. What they ask us to do is they want to take the patient home. And in home, the physiotherapists will come and try to help this patient. And what we actually, through analysis, we found out is that a patient who went home recovered quickly than the patient who is in hospital. Psychological problem, this is what we said, but we are not doctors, medical doctors. This is what we have to give a reason why we believe this. We believe that psychological and the presence of family around you and the atmosphere that this is your house, you know it, you grew up here, you had your kids here, it is more familiar to you than the hospital where you expected to see everything is in gloom and doom. So we sort of said that because of this environment, these patients tend to get better. So it's okay sometimes to move patients from hospital to their house and treat them there very cheaply. Particularly if you take Western countries, keeping a patient in hospital is very, very expensive. So you're talking about $60,000, $70,000 per year. Keeping a prisoner in Australia costs $100,000 per year. A prisoner. So keeping patient is more expensive. So I think sometimes thinking outside the box is good also, without going too far into it. Okay. Now, remember yesterday we talked about this. One of the reasons I left out is this one. This one we talked yesterday. This one we talked about yesterday. See this one? The heater. The hotter the data center, the more reliability issues it causes. And existing research shows that for every 10 degrees centigrade increase, you use 10 degrees centigrade, this is right? Okay. For every 10 degrees centigrade increase in temperature, the failure rate of a system doubles. So in your data center, if it's heating, sometimes the fans or the cooling system down, then the failure rate of the system doubles. If it was 2, it becomes 8. Or 4, so. Okay, so it is very, very important. Energy management is not only important to save money, but also to make sure that the systems are available all the time. Okay, so this reliability issue is very, very important in there. Okay, now we talked about cloud, right? So far I never really mentioned very well that there are multiple clouds that we can use. In passing, yes, we said about multiple federated cloud and this. Today I will actually talk about federated clouds, what I call actually hybrid cloud, okay? So, oops. A cloud is a shared pool of P personal private clouds. So the private clouds consist of a number of pool of shared of resources. Okay? These are our own private clouds. So every university can have their own private cloud. Organizations can have their own private cloud. Okay? So he was actually trying to build a private cloud. That is, we have a shared pool of set of clouds. And then we have a shared pool of rentable clouds. So the rentable clouds are public clouds. So each one of these are a cloud by itself, which is these ones that you see. Cloud 1, Cloud 2, Cloud 3. And this one is a private cloud. Company A has its own private cloud. Now, so a hybrid cloud, what someone here is calling it federated cloud, is a combination of these two. We have private cloud and there are many public clouds. So if we combine these two in some logical way or physical way, then we create what's called a hybrid cloud or federated cloud. Now, the reason I did not use the word federated cloud, I only use federated cloud because someone kept saying federated cloud. You can actually create federated cloud only by combining public clouds. Federation means combining. Hybrid means two different things that you can actually connect them. That's why I call hybrid cloud. But because now this federation also infiltrated into the concept of cloud computing, it's okay to use both of them. For me, I prefer to use hybrid, two different entities. And we have a set of users. These users are 1, 2, 3 n users. Okay? So it could be users of public or private. That okay so far? Any question? Okay. Now, you have to have a way, if you're actually using this, you have to have a way to connect them, right? There is 3-4 things you need. One is you need to build a gateway. Gateway from one type of cloud to access another cloud. That gateway has to be there, right? So this is what we actually did. This is a gateway that allow you to send your application from private cloud to public cloud. So if you have application that needs your private cloud is very heavily loaded, Now you wanted to use public cloud. What do? You have to have a gateway that allows you to send your application to the public cloud. So now this gateway have a lot of components here. I am sorry, I can't see them, so I have to get closer to that. So we call it inter-grid gateway. And it has a number of things. The one in here, the big one, says is scheduler, provisioning policies, and peering. So now this has what's called peering agreement. So we develop a mechanism to associate two different classes. So that is what, there are two different clouds. That's what peering does. Peering based on agreement, that two clouds will agree, saying that, remember we talked about buying resources from, when a cloud provider can't provide enough resources, they can buy from another cloud based on certain agreement between them. 70% maybe charging them instead of 100. That's what we're talking about. So the peering connect two cloud service providers or private and cloud service providers to agree. So they establish an agreement. That is what peering does. And there are other components. I will leave this slide with you. I forgot to put the paper here where this is actually applied, but I will give you the paper also later. Now, the workload that the applications will use is, in this case, we call a set of tightly coupled jobs that will be submitted by private cloud users. Now, I said I will talk about a hybrid cloud, right? Private cloud users using public cloud users. Only when they need the private cloud or public cloud. They always use their private cloud, but at the time they need public cloud, more resources, they will go and use the public cloud. And these are the jobs. I have already talked about these, right? So all these formalities, I'll just repeat it here. Type of required virtual machines. So every application that comes to the cloud service provider will say, I need a small, medium, or whatever type of virtual machines. This is what you have to do. If you want to use public cloud, Amazon or whatever, you first say the size of the cloud, the type of the virtual machine you need. So that is what this stands for. Now, the service demand, remember the one we calculated with hyper exponential hyper exponential distribution? That is the service demand of this particular job. This is deadline. We want this job to be completed at this particular time. And arrival time, each job has arrival time. Okay? What is stochastics you guys call, that is different arrival time. That also applies to service demand as well. Number of virtual machines needed. So that one is only the type of virtual machine, right? The type and number is different. This can be broken down into, I need 3 small ones and 4 big ones. So in this case, we need 7 virtual machines. So these are the kind of the things before you send your job or your application to cloud that you need to provide. Okay? These are some of the applications. You remember matrix multiplication? I've used this many times. And this is the workflow that we talked about yesterday. Was it something like that? Yeah. So these are the applications. All these applications will have these characteristics. Now the problem is that informally the problem is how to run user applications on hybrid cloud computing such that both user and cloud owners are happy. So cloud computing service providers are in business to make money. So we have to make them happy, right, when we develop resource provisioning algorithm. Users are there to get good experience, and we have to make them happy. So where to execute the application, public or private cloud? So if you actually have a private cloud, this question must be answered. What type of applications should be sent to public cloud, or what type of applications should be executed in private cloud, and when, right? So the second question is, how can we select the best public cloud? So I showed you that we have multiple clouds. So the other question is how to select the best cloud. How should job scheduling locally, mapping virtual machines to physical machines should be done? Okay? So these are some of the questions that I will only touch bases with, but these are open questions that you can actually try to look at them. Now, what the informal question that I stated is NB hard, and you can simply see for cloud providers. Okay. So the provider is interested in profit, right? So this is what actually I'm trying to capture here. The revenue lays away the cost. So the cost can include the energy cost, the power bill they pay, the amount of money they invested on purchasing the resources, the SLA violation costs they did. All this is the cost. So if you take the whole revenue they made, less cost, that will be their profit. So in order to optimize this is an optimization problem, and it is actually an NP-hard problem. We also wanted to optimize utilization of the resources. And this is the formula that you can use for utilization, particularly you two who are working in load balancing. So you can look at this formula for utilization of resources. If the server utilization passes certain level, then you can call it overloaded. So you can use this formula to calculate the overloaded, underloaded, whatever, for each individual server. Now, why we need to do this automatically? Because users actually can't spend a lot of time selecting which cloud computing is better for them. We need to build a recommendation system there, which I told you many times. It's an open problem. Nobody has actually tried their best to do, but a very good recommender will be in the hybrid cloud environment is still an important issue that we can work on. The reason we need the recommender is because cloud service providers differ in many aspects, right? They differ in their price, they offered the quality of the service they offered, the SLA agreements they can get in with you. All this by the semantics for data access, both for reading and writing, and by interfaces or security mechanisms implemented. So if you take all into this account, then we need a recommender that actually says this is the best cloud service provider. Now, reliability issues for hybrid cloud. So what this diagram basically says, resource failure is inevitable, right? Stupid me instead of saving my lectures, this lecture I didn't make it today. If you see, I'm like Phillips, as if I swallow battery, moving from there to there, have more energy. Because I didn't make slide. I was making a slide every night until 2 o'clock. Then get at 5 o'clock in the morning and clean the slide. But last night I slept. Because I made these slides before I came. All these lectures, I have them on my laptop. I didn't back up. Why? Because I'm stupid. I didn't think that it will fail. So the first sentence I have in there is it is inevitable. It happened to me. So it will happen to anybody. It's not a matter of it will happen, but it is a matter of when. Right? So I brought 16 gigabytes of memory stick, brand new. So my idea was, I gave it to Bilal. My idea was, when I landed in India, I will actually, the first thing I'm going to do is to put all my files, I already backed up home, but all my files on this. And I asked that they put this on this. At the airport, the laptop is gone. And all these 316 I bought, useless. Right? So the reason I'm giving you this is, don't be like me. So it will happen to you. Now I learned a very big, very expensive lesson. Expensive in terms of money, expensive in terms of my time, expensive in terms of my health. So one of the reasons I am now, my voice is like this, I blame on the auto, but it is also on these horrific dreams. You know, I ask you sometimes about, did you guys have dreams? Because I had dreamed that my laptop was repaired. But when I wake up and come, Shadat told me no, sir. But Professor Zahir said we have to have dreams. Yes, I keep dreaming. You see, that's the result of dream. I said it will be repaired before I leave. But I was sad. It only happened last night, which is one more lecture. But if it didn't happen, I wouldn't have shown you that the health things. Anyway, what this says is that you can have, we always think about a failure of the resource, right? What our research says is that failure in very large environment can occur along space and time. Okay? So when we talk about space, 2-3 servers can fail at the same time. Okay? So if you see here, this is just one failure. We're looking at a long time, right? But if you see these 2 servers fail at the same time, not exactly at the same time, but they occur, one fail, and why? Before we repair the other one, the other fail. Okay? And along time is the same. You see this one happened also at the same time, while the other 2 are failed. So failure can happen along space, along time, and along space as well. And what this also says in a simple English language is, one failure can cause many failures. It's just like in a traffic jam. One car accident, then many cars can form accidents. So when we talk about failure in large systems, we should not only look at failure as one node failing, but this failure can actually, if a node fails, so the hard disk fails, the other one can have network failure, the other one can lead, all these things can lead to many failure. So we are actually trying to solve this problem. It's not one node failure, but many multiple node failures. So there is correlation between failures. That's basically what we're trying to say here. So, cloud security challenge. This is Federated Cloud Security Challenge. I said I don't have a slide, but I do have a slide. Because I didn't, as I told you yesterday, I didn't touch any computer. Because I knew the slide was there. So here you go, the security, as I said, reliability, I actually look at it as security and fault tolerance. So one of the problems is how can we improve usability and security of entity credential management on the cloud. Now, Hakim is working on credential management. So he's actually trying to encrypt data and store it in there. Now, when you encrypt data and store it in cloud, the most important thing is that why you encrypt and store data in there? Huh? Come on, tell us, Hakim.
To increase security, sir.
Security.
To make secure.
Now, the problem is you need to access that data. Where you're using key, right?
Yes, sir.
Public, private key, whatever you. Now, if you want to access that data, if you send the key to decrypt that data and access it and then do some work and then come back and recrypt it, the whole idea of your encryption becomes useless. Do you understand what I just said? Because you're sharing your key with the cloud service provider. What is the use of storing data there if you don't actually access it, if you don't query it? So the first thing I told him when he asked me, can you query your data? Yes, there are now mechanisms that you can use. You can query the encrypted data without decrypting it there. So when you solve problem this is not a problem to just encrypt data and store it in cloud. We can do it, very simple. But the issues is really how to keep the credentials, right? Credential management. The keys, how do we keep it? Where do we keep it? So I saw one, I'm keeping it on my server. Your server is vulnerable. But there must be a way to ensure that you access your data when you want it. You can query your data when you want it. It's in the cloud. And also you make sure that your data is safe. Your credential is safe, managed properly. Otherwise, everything you have done is useless. Problem 2 is hybrid cloud opens up the possibility of misusing information to a degree never seen before. So one of the problems is insider threat, right? Particularly if you actually coupling your private cloud with public cloud. You have some data that's not supposed to leave your organization. Now it's possible this data to go to public cloud. So the issue is how to prevent it. Detecting and mitigating HX DOS attacks against cloud web services. This is another serious problem, okay, because anyone can use cloud at any time, right? People can actually cause denial of service attacks. How to detect these denial of service attacks and prevent them. So these are today's open research questions for you guys.
In this situation, then cloud services or cloud applications are not suitable for e-learning system in which you are having examination related activities in a large scale.
Yeah.
For example, big universities cannot use.
They can use cloud computing.
And how to manage the security aspect of the critical data which is related to...
That is the question I'm posing to you guys here. So, it is about reliability we're talking about today. I'll give you security lecture, maybe in the afternoon if we have time. But reliability with little bit security in it. Okay? But Hakim is working in that area. We have a big data and examination data as an application. How do we make sure that that data is secure? In fact, recently, was it last year? I think it's last year. I think it's last year. Year 12, you have year 12 here, right? Exam, national exam?
Yes.
Is it grade 12? What you call it? You call it?
Yes, different boards are there.
Yeah. So in Ethiopia, the exam was actually leaked. It was on all Facebook, and they have people written and have complained. I don't remember the whole issue, but the exam questions were right there on Facebook, and there was a big problem. Then they have to rewrite the exams, and they have to lock down everything. So that happens. So and very important to address security of these kind of things. But in some countries, I know for sure you can get the exam beforehand if you have 2 lakh, 3 lakhs. So it doesn't matter. Security, you can secure the data, but if you can provide 3, 4 lakhs, you may get half the questions. If you provide 10 lakhs, you may get the whole questions. It's a matter of just. So, do you consider that system secure? I consider it insecure. Right? Whether you get it the other way or you break into the system. The only good about breaking into the system is you can sell it for $50 instead of lakhs. Right? So this is what they do now. What they call them hackers. They have a website. They break into credit card providers, and then you go there and buy it for 50 cents, $1. You use the credit card to buy your airline ticket and whatever, but you get caught once in a while. So that happens. Okay. Let's come back to the reliability of cloud computing. Now we have a shared rentable public cloud, and each cloud consists of a pool of shared resources, and each resource is described by a table, which is this one: available service capacity, and service unit price, how much you pay for it, and service type. This one is whether it's CPU, storage, network, or service status, failed or working. So the status of this service, what I mean is it working in good condition or it's failed, okay? Now, the problem of resource allocation is given a shared pool of resources, which are public cloud, and given a set of jobs, the objectives is actually to minimize response time. This is what we call making users happy, and also minimize the cost. Again, making the user happy, but maximize the utilization of the resources. This is actually making the owners happy. So we're trying to make, as I said, both users and service providers happy, equilibrium, trying to do that. Now, the cost, I have talked about this many times, is basically for each resource, different resources, which be CPU, storage, network. It is the type of the service you use multiplied by the cost, the amount of the time that you used. This will give you the overall total cost. If you use different resources, the total cost will be here. Now, the deadline is basically the arrival time of your job and the service demand of your job. So if you add these up together, must be less than the deadline. So this is how we actually put the constraint on the deadline. Your job arrives now, and it must be finishing in 2 hours. So if it's 10 o'clock now, the deadline should be 12 o'clock. So that D, big D, is 12 o'clock. Okay? So So why did I take into account arrival time? Anyone? If I take this out, the plus sign out, is that okay? No, because you see, your service demand can be 15 minutes. Of course, I will be more than happy if I'm service provider. If you say I only need 15 minutes, but I want you to complete it 12 o'clock, that's fine, right? So you need to take into account when this job came. Otherwise, you will miss a lot of things as a user yourself. Oh, okay. Now, as I said, because we have private and public cloud, we want to make sure where to execute a particular job. So should we just keep it in private cloud or should we send it to public cloud? Okay. We came up with 3 different ways of deciding. Now, each one of these 3 different ways don't take security into account. Don't take the application type, sensitivity of the application type into account. This will be for you guys to do research and improve our approaches here. Yes?
I want to ask one question from the last slide.
Last? Go down? Or previous?
Yes, previous.
Last means the end of the slide. Okay.
Actually, suppose the request comes at the virtual machine.
Huh?
So, any request comes for the service at the virtual machine. So, firstly, we have to check how much workload is available at that virtual machine. So, we also add that load, and after that, we check the deadline. It means available workload at the virtual machine plus the job came the time duration of load of that job, which should be less than the deadline. So arrival time plus available workload at the virtual machine, which should be less than deadline of the task or job. What do you think?
Is that what you're doing? Is that what you're doing?
You are doing it.
Is that how you work?
Yes.
Why? Explain to us.
So actually, suppose a virtual machine is executing any task, and the
But
task
we are not there. We are not at the virtual machine. We are now here submitting the job.
and system.
Yeah, because we are now submitting a job. See? You see, we said we have a set of resources and a set of jobs. Now we want to submit these jobs, and one of it is to make sure that my response time should always be less than or equal to my deadline. Okay, now this is what I want to do. Explain to me your how you're going to do this in this formulation. You see, what he's saying is he is actually referring to the allocation time. When you want to allocate a job, you want to see what are the other so the jobs running there. That is completely different scenario. Yeah, that's scheduling, allocation. What I'm doing now, I'm just submitting a job to the resource. It's at the start, you just say, I want this job to be finished at 2 o'clock. The example I gave you, right? Now, it is once the cloud service provider accepts that, it is that cloud service provider's responsibility to apply what he said. Right? So we have not got there. How it is applied, that mechanism is completely different story. Right? That when you get there, if this says 2 o'clock you have to finish, the cloud service provider may not even look at this job until 1:30 because there are other jobs. That is different, completely different mechanism.
But here it means job, it means VM, not task.
We don't care. At this level, we don't care. This is a job. I am a user. I'm saying I want this job to be finished by 2 o'clock. And I need, remember, 7 virtual machines. How you allocate them, how you finish them at 2 o'clock is none of my business. It is your business. If you agree with me, my service requirement is to, service quality QoS is 2 o'clock. If you can give me this, I'll give you money, and here is my job. Whether it is job, task, this is not, doesn't matter here. What it matters when it actually allocation time. The load on the system matters also at allocation time. You can have, if you remember this earlier, a couple days back, I said, if you want service availability sensitive to the local load, you can build something called admission control mechanism. You remember this when I said this admission control mechanism will simply say I am loaded, I can't service this job, and it avoids it. That is before submission. Once it's submitted and accepted, the responsibility becomes the cloud service provider. That's when we come up with these scheduling algorithms, resource provisioning algorithms. That's when we deal with what you said. At this level, we don't deal with allocations. Okay? Is that clarify a little bit? Okay. Now, we basically say that you choose virtual machines, right? If you choose virtual machine, you choose the size. Remember this, right? Small size, medium size, large size. One way to decide for a job to run, whether in cloud, in private cloud, or in public cloud, is by looking at the size of your virtual machine or your job. So this is what size-based strategy says. Based on fact that the number of virtual machines requested by a job follows two-stage uniform distribution. So we talked about this, right? I gave you even practical class, Money implemented it. This is what we use, exactly. So based on this, we actually can have some of these variables. And what this strategy says is send wider requests to public and keep narrower requests to private. So big ones, we send them to cloud services, public cloud services. Smaller one, we will do it in local. So
some other options also may be taken care. For example, some secured service required may be in the private, and a little bit open or unsecured may go to the
I
public.
just said that 5 minutes ago. We did not take security into account. That is your job to do it, to extend our algorithm. We did not take security into account at all. So basically what I'm saying now, without security, if you want to add security to it, I don't do it, you do it. Okay? I am just now trying to tell you how to use federated cloud for different types of job. One way to decide is by the size of your virtual machines. Security is a big thing in there. Okay? Again, I will repeat, we did not do security in any one of these work. You take the security, extend this job, publish. Okay? Or sell it to Google or Amazon. If you want help, I will help you with that aspect of security. But we did not touch it at all. No, what basically this says is that take the smaller jobs and send it to private, and big ones send to public. So how do we decide? We use mean number of virtual machines per request to differentiate between wide and narrow requests. So we use this very simple formula, and we say this size-based strategy is very good when you have failures, space-oriented failures, not time. See, failures that occur, correlation along space line. Okay? Where multiple failures occur on different nodes within a short time period. So this strategy is good. Here is the strategy, very simply. It says you compute the mean value R of the two-stage uniform distribution using this formula, and this LMHQ-R. Remember when I talked about two-stage hyper exponential, we used these variables in there. So I didn't put it in here because I have talked about this many times. They are not new. Now, for each job in the list of the jobs, we compute the mean, the average of virtual machines required. Okay? So, do you know what I mean by here? Virtual machines come with different sizes. We want to find out the average size. Okay, so this is basically what we did. Find the average size, and now pick up a job. So we have job 1, job 2, job 3, right? We find the size, the average size of this. Now pick up job 1. Check it if it is bigger than the average size. If it's bigger than the average size, send it to public cloud. If it is smaller than that, send it to private cloud. That is what we do here. Okay? Now, the second algorithm is time-based. Okay, the previous one is size-based. Based on the observation that the request duration, that is service demand, job run time. In real distributed systems are long-tailed. Again, stochastics. We don't know the size of the job, but we're using statistics about the service demand of previous jobs. That's what it means, long-tailed. Okay? We already know that job service demand have distributions. That's why we use two-stage hyper-exponential distribution for it. So we are actually now, based on that, we're making decisions about the time of the job. So this means that a very small fraction of all jobs are responsible for the main part of the load. Most of it are small jobs, but only few of them are long jobs. That's basically what we are saying here. Now, ideal, this is ideal. You see here, short, from this graph, you can see shortest jobs take 80%, while longest ones take 20% of the job. So, ideal for time-based correlation failure, where the failure rate is time-dependent and some periodic failure patterns can be observed in a different time scale. So this is basically what this says, this really. Here is the time-based. Basically what the time-based says is that you need to compute the mean of the duration, the response, the service demand time, get the mean, and then pick the job and see if it is service demand is greater than the mean time. If it is, then send it to cloud, the public cloud. If it's small, send it to private cloud. Is that clear so far? Okay. Now, area-based. Now, area-based is actually combines the previous two strategies. So, if you see here, this is a failure, and this failure and this failure, so N1, N2, N3 are nodes, and you can see that there is a correlation between these two failures, failure here and here. And there is also correlation between these two failures. So you utilize the area of a request, which is the area of the rectangle with the length, this one, this is the length, SDG, and with the width, this is the width as the decision point. So we use these two information to decide. So making a compromise between the size-based and time-based strategy. So this is actually addresses the problems, the shortcomings of these two, the previous two scheduling algorithm. Or now this strategy sends long and wide requests to the public cloud. It will be more conservative than a size-based strategy and less conservative than the time-based strategy. Okay, here is the idea. You compute the average time, you compute the average size, and then you multiply them to get the average area. Now, so for each job, this is what you need to do. You compute now each job's width. Remember this one and that one. So we do that. Here we compute that. And now, if a job's average area is greater than the average area of every job, then we send it to the public cloud. If this is smaller or equal, then we keep it in our private cloud. Now, as I said to you, there is a lot of improvements to these algorithms. One is security, but they are money. Now, these are the three ways we decide how to execute jobs. What time? Okay. Now we come to his point now, what he was saying, right? So the allocation time. So basically, as you can see here, these are rabbits. Rabbits are queued, jobs. And then we have a dog. Now these rabbits try to eat the carrots. But what we want is the fastest one will eat the carrot. This is actually what Professor DP said the other day. You come up with your own algorithm, not meta-heuristic algorithm. You see here, that's what I'm trying to do, using rabbits. But I didn't finish it. You guys can take this and do it. Okay? The idea of rabbit, nobody did it. They have done everything. Okay? So you guys are too smart. You can finish it. I didn't have time. Okay. What the algorithm basically says is that we have threshold, we have waiting time of each job. You see now, waiting time there comes into the picture for you. And runtime of a job. We want to improve the slowdown of job I based on the if the system is, if the server is overloaded, then the waiting time increases, right? So that is where what we wanted to solve in here. Now for each job in a queue in here, we find actually a threshold based on waiting time and the runtime of the job divided by the runtime of the job. So if this job, how long it waited in the queue, and what is its execution time. If you add these two, divide by the execution time, you will get a threshold, which we use to assign jobs to servers. Now, if the slowdown is greater than the threshold, we actually now grant a reservation to job 1. So job 1 will go ahead and receive the resources. So we go through each one of them. We go through each job in the queue until we finish. So what this basically says is that we don't use first come, first serve. Right? We actually now look at the job, how much it has been in the queue waiting patiently, and if it keeps waiting there, what will be the slowdown that it will face in terms of service level agreement. If it exceeds the service level agreement of D, capital D, deadline, we don't want that, right? So that's what slowdown is trying to do. So the job now is turned now to get executed to achieve the deadline. This is what we're trying to do here. Okay?
So is this similar to earliest deadline phase?
No. They're not. Because what we do is we compute threshold based on how long this job is waiting there and what is its execution time. Remember earlier I said if the job comes, if the job comes at 1 o'clock, the service provider doesn't care when this job, the user doesn't care when this job runs. But the provider will run this job maybe, if it is half an hour, maybe it will start running it at 1:30, even though the job came at 10 o'clock. That is what this is saying. We decide, the service provider decides when this job should run.
Based on deadline?
Based on deadline and based on the current load. And based on how long it has been waiting. The short...
How do you compute this slowdown?
It's given to us a slowdown, right? Because the deadline is given to us, and you can see that if the deadline is going to be slowing down this job, if we don't meet that, then we're going to slow down this job. Even if we pass 0 seconds, then we will actually violate our service level agreement. Okay? Okay. Any question?
Said about before that you said about time-based, size-based, and merge. What is size-based?
In terms of the execution time of the jobs.
Then what is time-based?
That's the one I'm saying.
And size?
Size is the size of the virtual machines.
Yeah. And there is another thing I want to ask. How we can compare cost-based. That if I want to execute the job locally, how much cost it will cost, and if I want to export it to public.
That's another issue that you need to improve this one and address it. I said there are many things we haven't done in here. So there is a lot of possible venues that you can implement.
It means, can we calculate it as the energy consumption plus some fraction from initial cost?
Energy don't get into energy with multiple clouds. You will have some issues there.
Because for private we have to calculate the cost, operational cost. It includes energy cost and some fraction of initial cost or hardware cost.
The private one, you don't pay any money because you're using it privately, right?
But we will pay for energy, for
No.
operation.
No. The private one, The concept of private computing is the organization has their own resources. It is their own resources. It's running their own application. So unless you actually sell the resources, that cost comes in there. Operational costs is there. Operational costs is taken into account as a doing business. But buying resources from public cloud is additional cost that you don't maybe budget additional cost. This is the cost that you need to calculate. The other one, when organization always come up with their budget every year, they always include as a cost of doing business this amount of money. They already accounted for it. Unless you know exactly how much they accounted for that amount, which goes into energy payments, which goes into infrastructure purchasing or maintenance, then you get into problem. Because for you to determine the value, how much resources in private computing cost, you need to get data. If that data is available for you, you can calculate, not actually as a scheduling algorithm or this, but to make sure that the private cloud service users will optimize the resource usage for their own organization. But you need to know a lot of information, which I believe is not available online, or many people don't deal with it. The public, you have all information. We know that how much Amazon cost to charge you. How can you get that information unless you say we can also take that amount and move it to public cloud, private cloud. So if I actually use supervisor, I will say, prove it to me. How can you actually move this figure from here to there?
That's what I'm asking. That we need to run some VMs.
Well,
what we have done in our institute, that we compute that we need server for research. We need server, it will cost 3 lakh. We can use it for 10 years. It will cost 3 lakh in hardware cost plus operational cost in terms of energy. Then we found that if we take from Amazon 3 VMs or 4 VMs, for 10 years it will cost same. Then we decide to take from Amazon instead of buying the server.
No, what you say is totally different to what I have been presenting. Even as we have within university environment, some research group will buy resources and others to use it. Sometimes we say, okay, good, what do you call it? Just goodwill. We allow them to use it for free. Sometimes we charge them. But this has happened. What he's saying is that we did a benchmark. Should we use a private cloud? We build our own private cloud, or should we use a public cloud? Which one is cheaper? Huh?
Yeah, based on cost.
Yeah, which one is cheaper? We are not saying that. I'm not saying that. We already know that public cloud is cheaper rather than building your own. This is a well-known fact. But 99% of the organization have their own data center, their own infrastructure. This is what's happening now. In the future, I don't know. Okay? So if you go to any organization, they have their own data center, they have their own infrastructure. But what we're saying is that they can also borrow sometimes or rent some services from cloud, public cloud, when they need it, because they have their own private store. There is no option now saying we throw this out, because remember, many organizations have their own home-built applications or very sensitive data, very sensitive applications, and also they have a lot of things that they hide from other organizations. This can only happen if they have their own data center. So if you look at what he's saying is, we know that public cloud is cheaper. So we even anticipate that we start doing, actually in my university, you can study from anywhere. Do the same lab, the same exercise I'm giving here. You can actually sit in India and do it anytime and you want, because we are exploring the cloud. So the concept of live laboratory is gone, where you actually go into the lab, like when I did my PhD, we used to go in the lab. I don't know how many hours you spend now, but our time was very, very hard. We spent 16, 17 hours in the lab to do the work. But now students come 9 o'clock and leave 5 o'clock as if they're working. Time is only...
Not even that.
I am pretty sure he spent more time than me, because I know I spend about 16, 17 hours.
Nowadays they come leisurely and like something they have to do, so they will come.
Okay. So, see, the concept of, eventually, the concept of physical lab will disappear, and then virtual lab. So we know that because it's cheaper, rather than actually purchasing, this. Earlier, universities used to purchase the systems, the servers, and this. Now, then what happened is that they moved into leasing them for 3 years, so that when the 3 years finish, it is assumed that technology is progressing, they will get a newer version of this. So this disappeared, buying disappeared, leasing became very normal. Now, because of this cloud and Uber idea, sharing the rights and all this, the taxis died, right? There is no taxi now. This is Uber everything now. So this cloud also disappearing, the leasing, what becomes leasing the resources virtually. So this way things are changing. Because of, we know that it's cheaper to do it that way. What I'm saying now is, but there are organizations they will always have their own data center, where they keep and produce and innovate their own. So if you look at companies that produce robots for military, they will never do it on public cloud. They have to have their own data center. In health, even though we know it's more expensive, they have to keep the data within the health environment, because this is about patient data. So they can't actually go to cloud, public cloud. They will build their own private cloud. So there are always cases where there is private cloud and public cloud. So what I'm saying is now is, how can we use them together?
So this is the difference. What I am asking, this is hybrid cloud. The difference, federated cloud, it's not hybrid cloud. Federated cloud, both they are public. Both they are cloud providers. It's integration of multiple cloud providers. Then I am cloud provider and I want to use another cloud provider. Then which one? Sometimes running VMs on my cloud on my cloud, it's higher than borrowing from others. Then this is a
but I just said that we already know using private cloud is more expensive.
No, it's not private. I am cloud provider.
Yeah.
And I have a choice to use other cloud provider resources.
Yeah.
Then how to decide to use my resources or other cloud provider resources. Sometimes because of energy, then it's better to borrow resources and switch off my resources.
But
Sometimes it's opposite.
But this, remember 2 days ago, 3 days ago, I raised this question, and I actually said the fee structure has to agree, because you are both in business, and it is just like what they call them, this distribution, what they call them, chain,
Supply chain.
Supply chain. That's what he's talking about. I talked about this in length couple 2 days ago or 3 days ago, how to actually, in fact, the most important question is not what he says. The most important question in there is the trust, the fee structure, the abuse that can occur. Do you know peer-to-peer system that we talked a couple of years back? With so many problems, what we call something user, what we call, I forgot. A user that actually we always wanted to use somebody else's, but he never allowed his system to be used. Okay? So these are the issues. What he says is not an issue really, because it's easy. If I know that you are my competitor, why should I sell it to you in the first place? Why should I allow you to share mine?
There are many persons also like this.
Yeah, person is like
They
this.
seek the help from others, but they will never.
They
help
never
you.
give. They never help. That's actually true.
But there are many cloud providers, not only Google, Microsoft. There are many small cloud providers local in India or like this. They do like this. They have only small data center, and they use.
No, what you are talking is
from
that
other-
they are not capable, so they are hiring the services. Let's say if you are capable, don't have the services.
Yeah.
You take the loan when you don't have the money with you. If you have money, you enjoy the money.
You don't take the loan.
No, but you know also in another. Then I know some people that they have home, they will rent their home and they will rent another home because it's.
I want to rephrase his question, okay? His question is, there are 3 public cloud service providers,
Yes,
right?
then all of
So
them.
these service providers can actually do business together. So the interesting question is not they do business together. We know that. The supply chain example I gave you, that businesses do business together. In fact, nowadays, if the supply chain, remember, today we're talking about reliability, right? If the middle supplier to the store fails, say for example, take a plane, right? Now, if the plane, these people who say Air India, so Air India receives services from 3, 4, 5 people, right? They are maintenance group, which is not Air India, but they are actually subcontracting it. There are people who bring food. These are also subcontracted. Agents are subcontracted. So if Air India stop running one day, not only Air India get affected, these are also affected. You understand what I'm trying to say now? So they do business together. One failure, the main one in the supply chain, will affect every one of these. So what do? They actually come up with service level agreement. Air India will say, I want food, hot food, every time before I leave, 2 hours to be loaded on my plane. And the food subcontractor will do that. The food subcontractor will also say to Air India, what? If you don't run one day, my food is perishable. You know, once I cooked, I can't keep it. I have to throw it. Then you pay me. It's not my problem. So that is what service level agreement says. But Air India will say, okay, I'll pay you for one time only. Once I pay the next time, I will make sure that when the plane is ready, I will say, now you start supplying me. So this is a simple, nice way. But there is also airlines working together as a group, right? So if you buy Air India to Australia through, let's say, Dubai, What Air India will do is, because they don't have flight from Delhi to Dubai, they have a group called many names. Sometimes they call them four groups, I can't remember them.
Here they are calling it Star Alliance.
Star Alliance. So this is what Star Alliance says, is that I will give some money to Emirates. So they have Star Alliance. So Emirates will charge whatever Air India charges, and less than 30%. So if Air India charge you to go from here to Dubai, 200 rupees, Air India will pay to Emirates 100 rupees, and it will take 100 rupees. The same way, if Emirates, somebody wants to come to India, if Air India brings it, then Air India will get 100, the Emirates will get 100. This is an agreement between them. Now, but always, the first thing they do is that, do I actually fly to Dubai? If it does, Air India will take always. This is exactly what happened. What I'm saying now here is the abuse is minimum. They work together. They're not in competition. Star Alliance means we cooperate, not in competition. Now, let us translate to cloud service providers. What happened? I am buying because I know this time my energy is expensive, because the energy, the way you pay it is, at least in Australia, is by time. So if around 11 o'clock at night, most people sleep, right? The rate becomes cheaper. But in the morning and when you're actually cooking and running, the rate is very high. So if I am smart, what will I do? I will use candles during the day. I don't cook. I will go out and eat and come back. But at 11 o'clock, I will try to wash clothes. I will do this, very cheaper for me. This is my way solution. But another way of solution is what? I will tell my neighbor, I will use your washer during the daytime. At 11 o'clock, use mine if you want to. So what did I do now? There is an agreement still, right? But this is not good. This is what I call abuse, right? So this can happen. That's what I'm trying to say. One cloud service provider can actually abuse the other cloud service provider. This creates, we did a lot of research in peer-to-peer, in business-to-business, in e-business-to-business, where one business can take advantage of the other business. That creates an important research issue, but not on the concept of honesty in business doesn't exist. I'll tell you, business is there to make money. If they can reduce their energy now, they will use anything in the world to do. So if the small cloud providers can come up together and share the resources, that would be the fantastic thing. But if they say, look, I am going to slow down now because my revenue is going to be affected. When I get client, I will get the resources from the other service provider. I will run on their service because it's more cheaper for me. So what am I doing now? This is unethical business in plain English. But this is an issue also, an issue from business to business issue. A lot of problems, business to business, that we can research. So what he's saying is that these three can share their resources on a face value of what? Trusting each other. If there is trust, That is what they call the Star Alliance. If there is trust, that will work. Okay? But if there is no trust, that will not work. In fact, I have done, if you Google, I have done a couple of research papers published on trust management for hybrid clouds. It's a big issue. That's why I kept saying all these 10 days, we need a recommender in there. One of these recommender system, one of the components has to be a trust and security issue and all this, right? This system is trustful, and this system is secure, and this system can actually meet your service demand, right? But if they share, small service providers share, you need to also make sure that the service demand that you're asking is satisfied by this smaller. How do you do if there is no trust between them? I hope I have handled these questions.
Happy? Actually, there are many things like trust.
No, but just I want to ask that if you are provider, you don't care. Just tell me, I want to sell this VM in this price. We don't care about trust here. I have this VM, I want to sell it in this price, even if you give me your resource or not. Then I will decide, I will calculate that if I run this VM locally, it will cost more, then I will use you. You don't care if I will give you or not.
Okay, I agree with you, I don't care.
Means this is what I was asking, that I know that this VM with this price, I will calculate the cost. If it's higher, then I will take.
Yeah, well, you are actually looking at it from different perspectives. I'm looking at it from different perspectives. I'm looking at it from real one. You actually simplifying the whole process of the supply chain. It is a supply chain issue. You are simply looking at these are ideal situations. I'm saying they are not ideal situations. There are issues, a lot of issues that needs to be resolved. That's basically what we're saying. If there is an agreement that this costs $5, this virtual machine, the other one says $3, I'll buy from this one and use them. This is what we're doing right now, right? But if it is 3 different people, cloud service providers, why in the first place doesn't use its own? Why he's actually buying from somebody else?
Because the energy in another place, I am not saying neighbor, in another country,
Yeah.
electricity now there it's less.
Less.
Electricity price.
Yeah.
Then it's better to use that VM because my cost, maybe he will use, but I didn't say about this. Maybe it will be night here, it will be day there.
Yeah.
Then he will use my resources.
Mm. But this is not the reality. This is what I'm trying to tell you. The service cloud, I don't know about the service providers in India. The service providers like Google and Amazon, they already build in their fee structure that when we sleep in America, the Indians are up, we will charge them this amount. They already know that you are up. You will pay the same amount, whether you send it at night or you send it at daytime.
Yes.
Because that they already build the infrastructure in the fee structure that way. I don't know about the ones in India. I can tell you the big ones, they know when you sleep. When they sleep, we are up. So the energy you use, even though cheaper, but they will still charge you the same amount.
Data centers are also spread across the world, so it is not that their data center is not in India and they don't have it.
Yeah, yeah. So the small ones, they can be actually within India, right? But I actually don't send my job to small ones because they're more vulnerable to security, more vulnerable to reliability, and also they can disappear within, you know, if you run all your jobs, your data is there, and tomorrow if they disappear, what would you do? With your data, it's gone. So I don't know how the small ones work. The big ones, they also have data center here. if they know that the data center is here, they can actually charge you the same amount within here. You can't actually ask them, I want to run my job in America when you are sleeping.
We are getting late, sir, now.
No, then we have no time. What time is it?
It's already
12:45.
10 to 1.
Then we will come back and finish this. We have no time. Okay? We take break and come back.
We can have a group photograph right now.
Okay.
Because some of them may leave.
Okay.
Yes, sir.
वो डालना है सर गिव यू पोस्ट डालोगे इसी से दोगे देंगे
Okay. So let's continue from where I stopped. These are some of the parameters that are used in performance analysis. Here is how you might measure the slowdown. Slowdown is measured by the number of machines you have. That is, you basically take the average of the waiting time and you take the maximum of the bound. This is a variable that we defined somewhere here. You can find that one in the paper also. You take the maximum of these two and then divide it by that for each machine. WI is the waiting time, TI is the runtime of each job. And we also measured the cost. As you can see, this is the cost of the public cloud per hour. This is the fraction of the requests that are running on the public cloud. And this is the startup time for initialization of the virtual machines. And this is the cost specific of one specific instances of virtual machine or resources, which is like 0.855 cents of US per hour, per virtual machine, I mean. And this one is the amount of data which is transferred from the cloud, from the private to public, and from public to cloud. The deadline matrix is generated like this. The runtime of the application times some factor of the arrival time, where this factor is greater than 1 if you're using different types of distributions. Normal deadline is, for example, F equal 1 to 3. And CTI is the time the job completed. So based on this formula, we can actually get a deadline for each particular job. And these are some graphs that shows, depending on I forgot where I defined. It's here. Okay, the service type. Okay, you see this service type. So now we run. This is service type, different service type, and against the violation rate. We are talking about SLA now, service level agreement violation. You can see that violation rate as a function of the job arrival rate. You see that this the size based is the best one, as you can see, is almost flat, whereas the worst is that one which is time based. Okay, so this is again now you looking at violation rate as a function of the request size. When it's the size, you will see that still the time-based is not performing well. The size-based is doing much better. Violation rate as a function of the job duration, how long they wait. You see again the size-based is much better than the other one. Still, area-based always follows along the size-based. And slowdown for all provisioning policies, you can see that now the size-based and combining size-based with some other scheduling algorithms. These are a combination of scheduling algorithms, which I didn't talk actually. These are the local scheduler, local machine scheduler. I don't have time to talk about them, but if you want, I will give you the paper you can read. Again, if you combine the size-based, time-based, area-based with one of these scheduling algorithms, you can see still that the size-based is doing much better than the other ones. And the area-based is always tracking the size-based. If you look at slowdown for all provisioning policies, again, for just slowdown, you see that the area-based still, the size-based now performs, and the area-based is always follows it. Slowdown as a function of service demand. Now we are actually looking sensitivity of service demand. You will see that again, the size-based and the area-based are doing well. Now, if you look at the cost for cost provisioning as a policy, now you see that the time-based becomes much better. The cost, when you take into account the cost, then the performance completely changes. The size-based is actually becomes harder, because the larger the size, the more you pay. You understand? So that if you send the large jobs to cloud, you pay more. So that is why you see that this is performing much better. So again, you can see now the time-based is the one that's doing well as compared to the size-based. But as you can see, always the combination of these two, the area-based is always closer to the best performing one. Again, cloud cost or EC2 for all provisioning. You can see still the time-based is performing better. Whenever you take into account the cost, the area-based is going out of really fast, becoming the most expensive one. Okay. Now, we actually started this course with talking about cloud. What is cloud computing? That's what we start with. And hopefully, by today, I have cleared up some doubts. You have many of you ask me what do you mean cloud? What is cloud? Where is it coming? Where it's going? Why it's not coming my way? All these things, I hope I have clarified little bit, if not all the doubts. And if not, you can tell me, and I will still be here. I will just change my ticket and stay here. Okay. So, my definition of cloud differs from many people's definition of cloud. So, my definition is it is a utility-oriented, it is a distributed system, and consists of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreement established through negotiation between the service provider and consumer. So my definition has negotiation in it to negotiate service level agreement. It is virtualized. It can be one cloud, or it can be more cloud, which is hybrid cloud. And it is the resources are dynamically provisioned and you pay for it as if you're paying for your electric bill. So this is my definition of cloud computing. And the cloud computing, I said, is divided into three services. This is software as a service with example of Salesforce, platform as a service with example of where you develop your systems with example of Microsoft Azure, and then infrastructure as a service where you buy CPUs, storage, and so forth. This is Amazon is as an example of this, and users are the ones who can actually buy these resources on subscription based. And some of the advantages of cloud, you believe that the resources are infinite or infinite, even though they are finite, because you can scale up and scale down at any given time. Accessibility from any time, anywhere. This is another advantage. Eliminates upfront commitment of users. Purchasing, reduce costs, pay per use. No need to plan for peak load because you can scale up and scale down. Easy management software versioning and upgrading. You don't have to worry about any of this management because all you care is you use the service and pay for it. Of course, these advantages are also mitigated by some risks. Performance issue becomes a very important issue. Security becomes how much you trust your provider. What about recovery, tracing, and data integrity? Who access your data, and so forth? All these are issues that you need to actually look into. This morning, many people have raised this because the focus is not our security. I didn't go into this aspect very much. We then talked, I'm just revising what we did. We talked about how to make computing energy efficiency. We looked at many different ways. Virtualization, system, what is it? System resource management, target systems, and goal-oriented systems, power-saving techniques, and workload management techniques. So these are also the techniques that we discussed in this workshop. And we looked at hybrid cloud today, and we said that this hybrid cloud is this is a resource manager for the private cloud, able to start, pause, resume, stop virtual machines on physical resources. It's able to migrate virtual machines from physical machines, so from the private resources. So you can look at this as one layer of cloud computing, private cloud computing, and these ones are public cloud computing. We have a gateway that actually allow us to use or decide which one of these platforms that our job will run on, and we looked at size-based brokering, time-based brokering, and area-based brokering. Cloud selection, I actually didn't have time to talk about this, but we built some algorithm, greedy algorithm, and then we improved it with particle swarm and greedy algorithm together to select an algorithm, a particular node in here, a particular cloud. So at the end of the day, I thank you. And as you can see, how should the new solution be, which is cloud? If you still say exactly like the old one, I will stay. If you say no, we change, I will go. So thank you very much. I have actually now finished all my presentations, and I am happy to see if you have a couple of questions, and otherwise we will cry and say goodbye. Thank you. We still
Sir,
have.
in the morning session, I have one question, sir. Actually, sir, Hakim taken lots of time. That's why I was not able to ask any question. So, sir, in the morning session, sir, you were discussing time-based algorithm and size-based as well as area-based algorithm for sending your application or your data to the private cloud or public cloud. Just like I think these algorithms are decision-based algorithms, so that we can decision whether to send the data to the private cloud or public cloud.
They are just like what algorithm?
Decision making, sir.
This is, yeah.
Yes, sir.
Okay.
So, sir, I want to ask a question. Can we design an algorithm based on security of data or sensitivity of data? Just like these three algorithms. These are based on time-based, size-based, area-based. Now, I want to ask you, can we design an algorithm based on sensitivity of data? If it is more sensitive, then run it on private cloud, or if it is less sensitive, then run it on at public cloud.
But that's the question he asked me, and I responded to it.
Well, sir,
You can. Sir said that you modify these things, he will help you. You can definitely do that.
but sir, one more question is that if we will design
Is this question answered, or you want me to answer again?
yes, sir, you have to answer again, sir.
Okay.
Sir, I understand this question.
Okay, okay.
One more thing, sir.
Okay.
If we can design this type of algorithm, then what will be the parameters on the basis of we can
No, the
design?
parameters is up to you. Don't ask me this. Because if I give you parameter, I will do it myself and publish it.
Sir, partially, sir.
Thereafter you will say you design also for me.
Yeah.
But sir, don't
And
tell
write
me
the paper
all
for
the
him.
parameters. You can tell me some partially, sir.
Did you also understand what the professor said? You will come for full then. You start with partial. It's just like, you know, someone, you open the door a little bit like this and you want to talk to them. They will hold my hand and slowly get in your house. Huh? Yes, you can actually apply sensitivity to the job. I said this at least on 2 occasions. He asked the same question. First he asked, I responded. He asked, I responded. You ask, I'll respond. Anybody ask, I'll respond again. Yes, we did not take into account security of the job. One of the ways, one of the extension to what we did is add security. Whether it is a job or whether it's the gateway, whether it is the scheduling or the middleware, whichever you want, you can actually extend this in many, many ways, saying this job should not be executed anywhere else, but except in a specific area. Okay, so if I give you an example of earlier what I said, some taxation data cannot leave India, right? So it has to stay in India. These kind of applications will always execute somewhere in India, Hyderabad, Chennai, whatever, but they can't be sent to North America and California because this is by law. It says the data should stay here. So the cloud service provider's responsibility is not to accept it. It's the people who are here make sure that this data will not go out there. So that you can do it. Yeah, you can extend it. About the parameters, how long it take you to get from JNU to Jamia? Jamia and back?
80 minutes.
Depends upon Hakim.
But multiply that by 10 days.
800 minutes, sir.
So which one you prefer?
Question is not clear.
Your question is not clear to me also. Okay? What I'm saying is you can choose 800 minutes or 80 minutes. Whichever way you go is whatever you solve. If we agree with it, that's fine. The other way is, you know what, my preference is, you should design, do you know this, what they call them? They call them this pilotless planes, drones. You see, the idea is to design drones to get from here to Jamia, to drop your jobs there. So the parameter is just developing that. What will it take me to develop drone? And for anyone who wants to go to JNU, we will just take them and drop them here. Any other question?
Thank you, sir.
Anytime. You can ask more questions if you have.
Already discussed so much, sir, but maybe a little comment from your side on the use of quantum computing in scheduling approaches. A little comment.
Quantum computing is a new computing coming up. Particularly University of Waterloo in Canada is actually working in this area very much. And the area I see in quantum computing is what is called quantum cryptography, quantum security, where actually things will get much interesting to solve security area in there. I did not actually pay a lot of attention. I know that the professors who are working in this quantum computing in Waterloo, and I didn't actually spend a lot of time trying to knowing what about it, but they told me that mostly it is for security, for very it is going to be very fast, very secure to do very things like this. But it is going to be much better than what we have now, definitely. I don't have a lot of information about it that I can share with you now.
Sir, are we using same computer or traditional software for quantum computing, or we create or we manufacture something totally different?
But that is the way you do. You need to come up with a new way of it. It's a new computing, and then you will come up with a new software.
Bit will be the 3 positions. 0, either 0, 1 or superposition of 0, 1. Now at the same time 0 or 1.
That when we are working on 3 bit.
There is always be new applications. There is always be
with the
old applications.
Yeah.
How many of you know COBOL?
Superposition of 0, 1.
COBOL.
You know COBOL, huh?
No,
COBOL.
I just heard
COBOL language.
Mobile programming language.
common object.
Still common. Do you know that?
Common object business oriented language.
Yeah?
Common object
You program in COBOL, huh?
No, sir.
No? That's what he says. You're programming COBOL.
I think none of the organizations are doing programming in COBOL.
Yeah, it's still common actually.
Are they doing something?
Yeah, so it's still what happened is that because they spend a lot of money doing this, they still maintain it. They're not actually doing program. No, they still maintain this, even though they can spend less than 1/3 of what they spend on maintaining. They refuse to go away from it. And also these big companies, I don't want to name them, they also have interest in maintaining this because they can make more money here for using their own system, and this, they will not actually let them remove from this. So the reason I brought this here is the old ways is still there, the programming. We still have a lot of C program based applications. We still have C++. Now we move to Java. And now we are talking about what? Python. So a lot of things about Python. But they will still be there, packets. And we'll have always a mesh of all the new, middle, and so forth. But the problem is when you can't use it. See, a lot of security issue comes from this because the programs were buggy, The hardware is also easily breachable, and as your system gets older, it becomes more unreliable, more unsecure, and you go into eventually you say, okay, I'm going to a new way. Until you get hit, you always stay there. But not too many people want to leave their comfort zone. This is where the problem is. Hakim will make a lot of money in this area with security problems. Huh?
Yes, sir.
Other questions?
No question.
Do you have something on cloud security also? Some of your publications that you publish.
I have a lot. So, what do you want me to say about it? About
What are the issues in cloud security?
oh, a lot.
इन्होंने कुछ प्रोफेसर के साथ काम करा है.
This is security on social. What do you call social network? So what happened is that in social network, Twitter and whatever, you actually send a message, right? You tweet anything you post, your photos, everything. And what we don't really know is that this data is published. Okay, so basically the way it's published is when we do sentiment analysis, we actually know what you are, what you do. So, see what, I'll give you an example. What basically this says is that we wanted to prevent this data that you submit to be appropriately used. The way it is now is Google, what is called Facebook or Twitter, they sell you data to a third party. No, the pure data to do analysis and see. You see, before when you do advertisement, you actually do in arbitrary way. You may win or you may lose. Now it is targeted because the data is there. We know the data. So in fact, recently, if you go up and read some information on this, in one country, there were a lot of teenage pregnancy. Okay, the young people, young girls getting pregnant. So what happened is that they sent a lot of these texts, I'm pregnant, I'm this and this. Two examples I'll tell you. One is the girl was actually friend of her father, and she posted saying, I'm pregnant. The father knew about it, but she was thinking the father doesn't know. One. The second one is that she went to a doctor, and the doctor told her she's pregnant, and he posted a message saying the young girl was this. And the father was able to track the whole thing together. The third and the most interesting thing, is that these teenagers go to the mall most of the time. So the Kmart was able now to get all this information, and as the girls pass the shopping, so they were able to know whether she is 6, 7, 8 months pregnant, and offer her baby clothes, baby items, some for free, some for cheap price. So they know who is pregnant and who is not pregnant. They send them on their mobile phone. And their sale went up, and their profit went up like hell. So, but they got sued because they did not about the data, but they did not actually agree for them to send them on the message. The data, you posted it, it's your problem, right? The business didn't do anything. You said, okay, I'll post the data, you post it, and I bought the data, I'm using it. But the suing came from because I did not ask you to call me or to send me the message. You did not have my permission to send me on my mobile phone. On that basis, they stopped them, not on the basis of this. So our work is actually now to make sure that this data that this social network operator will sell will be undistinguishable from, it will not tell you who this is. Okay, this could be Hakim. There are 10 Hakims. Which one you don't know. So that is what's called sanitization. But this is done on cloud computing because the data is stored there. Okay, so this is one of the problems. Many people, again, you see. These are some ways you can actually figure out basically what this says is that if I know you have four friends in Facebook, even if your identity is hidden, I will easily discover you, who you are in the data. So the data that they say, we remove your name. But if I know that you have 4 friends, who they are, you see in this case, the degree, this person has 1, 2, 3 friends, right? And what this says is that not only he has 3 friends, but one of these 3 friends have 2 friends. So this information is enough for me to identify who you are. So there are many ways to identify friendship, and then still, even though some people say we have actually sanitized this data, but we can show you in many ways we can perform attacks given a graph. All this is about that, and if I don't know if I have this, there are about 4 or 5 papers on this that we publish. These are 3, but you can find about 5, 6, 7 papers in this area that we published last year. Okay, so this is one of them. The other area that I work on is trust management. Okay, so there is particularly if you have cloud, hybrid cloud or federated cloud, whatever you call, we wanted to find the trust. I'll see if I can find it. I will just talk about things I did. This is about big data. Also, we work in this big data also in. See, I'm very much interested in agriculture because, as I said, I want to help. Someday go back and help this in my place of birth. So I actually did a lot of big data also, and this is actually from last year. We call GIAN, I don't know what you call it, in Mysore. I did the same program like this last year, so it's just from that. This is from there also. You can see many challenges with big data analytics. Security is one of them. I can't find it. I don't know where I put it. See, I went to Madurai now I remember. Huh? Madurai. Salem, Mason, I don't know what this MSRIT stands for.
Data intelligence.
What is this one? Sidaganga. That's maybe in Malaysia. That's VIT, Valorgan. He's talking to his phone. He can't listen to me. Oh, okay, I remember now. 2016.
डॉक्यूमेंट अटैच नहीं कर सकते ग्रुप में गुरुजी बता रहे हैं नहीं होता मतलब
One, I don't really remember a lot of it because I have a lot of different places slide. One of the things is websites against homography attacks. So this is actually can be used also with clouds. You know that homography, right? Homograph. Internet, you can write it in Indian, in Amharic, in Arabic, in many languages. But before, you can only write it in English alphabets, A to Z. But now they change it to what is called, what they call them here, let me see, Unicode. So this Unicode, sometimes Unicode O means different thing in different languages. So you can get the what you call website. You can create website by making look like Bank of India. Now the I is different. In homography attack, you just change one letter and everything looks like that. So just look at the way you type O and 0. If you don't pay attention, they look alike. But in homography attack, basically that's what people exploit. They will actually put one character and say it looks exactly like, let me show you, I have example. It is like that instead of now 26 characters, now have 100,000 characters to choose from. So see what they used a lot, PayPal, right? This PayPal can be actually put in a different way. It's PayPal, the spelling is the same, but underneath it, it gets translated into different address of a website. You don't you actually see the PayPal. You click on it, but the address is different. And then you pay money to PayPal. But the money is actually credited to another company. So that is called homographic attack. Phishing, people use this a lot. So we did actually solve this problem, but I can't find. It is published last year in a conference called SecuCom. So anyway, that is one aspect. The other is data storage. It's still a lot of security issues. One is like what my friend Happy Friend is working on is securing, encrypting data on their own system and ship it to cloud. Actually, that's not a good idea. Why? Because if you want to ship the data there, you need to ship it in chunks, the best way now. So instead of taking 30 gigabyte encrypted, that will take you 10 months, 6 months, because it's big data, right? Encryption takes a long time. So what people now start doing is break this data into smaller, okay? And then keep the reorganization of them, the index in your own area secure. And then encrypt these smaller ones and send it to cloud. So what that means is that if I get a portion that says Jemal is teaching in Deakin University and just came from GNU, that is about me, but nothing about my family, my wife. My wife's data is somewhere else. So for a person to find out about my family, they have to find all this data from different places, which is very difficult. But if you give them the whole data in one place, then what happens if I broke into this data? Then I have everything that I needed. I don't have to do. So what is the idea is make it very expensive and very time consuming for them to find the whole data they want. Of course, they are, hackers are not after me. Hackers want to embarrass me. They have to find all my data, my family. If I had girlfriends before, all my girlfriends' data. I didn't have one, but I'm just passing this, just to say this, right? I didn't have one. So all this, they have to get all of it to embarrass me. But if I'm smart, what do? All my girlfriend's data will stay somewhere. And all my wife's data will stay somewhere. I will stay in different area. How do they find? That is the challenge hacking faces. You give them all data in one place. So, see this idea. If this idea you can work on, encrypting smaller data is fast. But encrypting big data takes a long time and also one point of attack, where we're trying to make it multiple points of attack. People will get very tired, or if they can't get all the data, they will give up. Even if you take one piece of the data impossible for them, they will give up. Is that good?
Yes, sir.
Good idea.
Yes, sir.
Okay.
Inshallah, I will implement this idea very soon.
Okay. So let's see. Now, the other problem that of interest from security perspective, you encrypted this data, but you need also to search it, right? You don't want to bring data to your system and then decrypt it and work with it. You pay for all this. Remember, all 10 days we're talking about minimizing cost, but now you're actually increasing cost. So the idea is not only encrypt your data, but also any person, authorized person, should be able to search the data, encrypted data, no key transfer, nothing, just but mechanism to develop to search encrypted data. Okay, the most important one is you encrypt data, particularly the way I said, encrypt each piece of data. But where do you keep your keys? Management of the data is now useless because you encrypted it. The most important is keeping the key secure. Because if the hacker gets access to the key, they got everything. You can't trust the users to keep the key because they always write. You know, in many countries, they even share. They will tell you it is in this box and go and get it. So Hakim showed me one guy who's storing his data on the server. The server is internet connected. So how secure is that server? It's easy to break into the server that's connected to internet used by the user. Most users don't care about security, they care about performance. So keeping the key, the encryption key, is extremely important. Not the encrypting the data, but the encryption key is very important.
Sir, can we apply the concept of steganography for hiding our keys?
Yeah, you can apply, but where do you keep that? You know what he's saying is that you have Mona Lisa. You know Mona Lisa?
Yes.
You know, so in Mona Lisa's picture has a lot of spaces, you know, bits. Sometimes you have a lot of zeros. Replace those zeros with the key. Yeah, so you're hiding in there. And then people think it's only pictures, right? But many people know that you're hiding something in there. If you always display Mona Lisa, right? So there is a way also to break it. Most of pictures have patterns, real nice patterns. In fact, if you look at facial recognition, it specifically looks for some specific area things. If by any chance you put your keys in the face, and the face is completely talks about, you know, a donkey face, then I would suspect there is something in this donkey face, but she is woman. How can donkey face is there? Something must be hidden in there, and I can actually do that.
Even women's face also, it looks differently 2 times. Let's say morning they are different.
Yeah.
And in the makeup they are different.
Exactly. Yeah, in the evening, you see, Mona Lisa can put on makeup, right? So, and lipstick and everything, so it can change. So, I think the most important thing is really what we did when in the grid era. To use grid computing, you need credentials, and then my group actually developed something called credential wallet, where you actually, it's just like a wallet, you keep your credentials in it. So to use it, you don't actually use the credential, the original credential, but you use something called, I forgot the name right now, but you actually delegate. So delegate the access to the system, to the cloud computing system. You will delegate that responsibility to actually get you the data. But with just delegation key, it's not the original key. This delegation key is only one-time use. You can't use it for any purpose. Or if Hakim get it, he can't use it because it has me. So the best way, I think this is, sometimes I'm biased because I'm only telling you what I did. That's what I did. Simply, we developed a credential wallet where we keep our credentials and then delegate to resource management where we need to access data. The resource manager wanted to access data to process application. This resource management don't know the original key, but they get the delegation key. This delegation key will allow them to access the data from the file, process it, then they will never use that key again. Even if they use it, they won't work. So we did something like that, maybe try that. The other area is, as I told you, the insider threat. The threat that comes from inside of cloud computing. Okay? Any other? I hope that will give you a little bit flavor of security also. Any other question you have? Or you are ready to get your certificates and go?
So this is the last opportunity when you close.
Initially, sir, there was a lot of focus on DVFS. Isn't it? But
Yes.
I have read a paper and followed, and you have also presented a work in which you have taken the complete scenario into consideration. So basically the thing is actually in DVFS there is a lot of problem. Even though you are slowing down the processor speed, but the network is alive and the peripherals are alive. So it doesn't actually lead to any energy consumption.
No. Yeah.
Although actually you have also
That's absolutely correct. If you don't ask me, I'll ask you a question. I have been speaking for 10 days. Can you guys just, instead of writing a feedback on a paper, can you give a feedback? Who wants to start?
To the dais.
Hakim, sir.
Huh?
Hakim.
Okay.
No, any one of you.
Actually, all of you, not any one of you, because you know feedback can mean one thing you got out of here.
they want to keep it secret.
Actually, they told me that because the two professors down here, they can't ask any questions or they can't say anything. You want me to ask them to go?
Yeah.
Yeah? You hear? They say yeah.
Go with the certificate.
No, it is not that because of us they cannot ask. Even we are sort of a booster for them to ask. We start asking so that they can ask.
Okay, who is gonna give me a feedback? Me. Okay, forget them. Think them virtual. Nathan? Okay.
Any of you are no, you can go to the answer. You can use the mic. Let's see.
Hello sir, thank you sir for such a wonderful lecture, and first time I listened this lecture in which we got this vertical knowledge, the depth of one complete subject. Otherwise normally we only hear the lectures that covers. So otherwise normally we listen the lecture that covers only this upper part of this particular subject, but the first time we learned the depth of this knowledge, and the most important thing, the two things that I learned, that how to model something by considering all the particular parameters. And the second, the very important thing is I learned the open research questions that you have written. So that is really encouraging for us. So thank you once again for all the lectures.
Thank you very much.
I really learned a lot from this thing.
Thank you.
Thank you, sir.
Yeah, thank you.
Practically, we were actually somewhat susceptible. On the first day, you said that your system broke down. But at the end of the day, we could realize that how much efforts you have put up for us. I mean, every day you are saying that you are sitting in the library and doing so much of hard work to prepare for the next day. And that actually motivates us. I mean, even after doing so, I mean, the dimension of your work is so much that we actually able to dive it in and probably would not be able to come out of it. I mean, every domain you are saying that, okay, this is there, and then probably coming out with few papers. Okay, this is there, I mean, security is there, then IoT is there, all those things. we are actually able to find it out that okay, we can work with GIL and probably we can start even if we have not done anything in it. Thank you very much, sir.
Thank you very much.
From day one, he is not having his slides because this was broken.
Yes, that-
not broken. Yeah, it was broken. And then every day he prepared the slide and came forward with the slides. And we never felt that your laptop is not here. So that way, the kind of effort that he is putting. And at the age of, sir, don't disclose your age. At the age of, you don't know, but you can just imagine the kind of age he has. And I am also old age only now. So you people rather, with such such a good stage of health and everything, so how a lot you can put on yourself to, let's say, work hard in this particular domain or in any of the domain that you are. So you can just learn from Professor Jemal. Really the commendable job that he has done. Because the very first day he did not damage, it was damaged. The laptop was damaged, and the kind of a preparation he put behind that. The tutorial as well as this, I thought that how he will survive for 10 days. Really, initially I thought that how he will survive. But you see that the kind of effort that he has. So really commendable.
Thank you very much.
If others also want to speak something.
Sir, it has been a very nice experience to hear you. In fact, I have been following you in the workshop conducted by Professor Vidyarthi sir and his colleague. And in fact, that motivated me to come forward and listen to you. I think last year you talked about energy management in the workshop. Above all, one thing I will say that whatever question we put forward, for every question you are having a full paper, not a small answer. So that is really motivating for us that for everything there is a solution and you are having that solution. And above that, for every aspect you try to explore that you find out this, you find out that, and the very honest effort you put forward for all the things. Even if you are having something left in your paper that either you are planning to proceed further or you are posing it as an open question, definitely that will be giving a clue to the researchers who are looking forward to it. And in the last but not least, I will say the kind of humility you carry and the kind of personality you are having is commendable, and it gives a very good lesson to us. And definitely one mantra I have taken from you from yesterday, that no matter whatever you are today, try to be a little better tomorrow. Thank you.
Thank you so much.
Yeah, sir, just I want to say that I have done my MTech in resource provisioning and now I am doing in PhD. Then I studied for about 2 years in resource provisioning. Really what I studied in these 2 years we cover in these 10 days. Means it's full state of the art for resource provisioning, and who attend he has full overview for resource provisioning. And I could not find any similar course, even in internet or in any university, that usually they take cloud computing. When they teach cloud computing, it's not like this. They teach us as programming or how to make programs for cloud computing. Then I didn't find any similar course like this. It was very good, but just maybe I have negative feedback for coordination, that when I mailed only before 2 days and they told me it was mentioned in poster that accommodation will be provided. When I mailed before 2 days to guest house, they said no accommodation, it's not possible in this time. Then I think it should be organization should be done before that. It should be available, even if not in guest house, in some hostels.
See, that,
Thank you.
that is true.
Well, because I am lucky that I have some friends, otherwise I can't come.
All are lucky that all are having the friends, right? And that is a good thing that you all are having the friends. That is very important. And the thing is that we have written that if available it will be provided. We thought of managing it, but we remember that when I and along with Dr. Zaid and Professor Jemal went to see our Vice Chancellor, we said the same thing to him also.
Yeah, that's true.
He knows it. We said that we could not have more participants because many of them have written to us that kindly provide the accommodation that we do not have. Unfortunately, our hostels are not meant like IITs. I told the same thing to Vice Chancellor also, that even the IITs manages the accommodation in the hostels, and that we are not able to. Even Zahid proposed one step forward. He said that, sir, you can design or you can construct a guest house for a dormitory, let's say for GIAN program, let's say GIAN hostel. Something like this also he suggested. So this is the thing that is not in our hand, to be very frank.
I am not saying about
You said organization. You said coordinators, right? So that is, so I have to respond.
Because my relation, I will not go to vice chancellor, or I will not go to someone else.
So that is what I am also. You cannot go to, I am the medium, right, in between the vice chancellor.
I think in the next iteration of these kind of things, I'm pretty sure that this will be resolved. At least if I am involved, we will get ready for it. We will make all of you happy. Any group, okay? So hopefully this time we will learn from this. We have learned from it. Next time we will do it better. If any inconvenience, if you feel inconvenient, there is no one should feel inconvenient more than me, because I'm staying there. I myself actually brought myself down and stayed there. Don't feel, because you couldn't find place and didn't stay there. Because it's not sometimes in their hand. They only provide what they can. And we should accept whatever comes, but hoping that it will be improved next time. It will be, for sure it will get better and better and better. But I think they will learn from whatever happened now. Don't worry about it. And if they made mistakes, please excuse them, because they have done their hard, whatever they could. Next time, they will take this on as a board, on a board, and then they will improve it. Hopefully, what you should wish is we will have such kind of arrangements, many times. Even if it's not me, but somebody else, with their help, will come here, and you will benefit from it. So they will do it for you, not for themselves, okay? Sorry, I'm not speaking on their behalf, but I'm speaking on my behalf.
Since the beginning of this program, actually, we got many queries and many requests regarding the accommodation. And we made it very clear to all the participants that accommodation is limited. And we really tried our level best to arrange accommodation for you people. But since, JNU is a big university, so many departments, so many programs running over here, and this is a month in which actually mostly it is busy. Since December, usually it keeps busy. But still, we arranged few of the rooms in our one of the guest houses, which is Aravali guest house, in which sir is also living. And after that, after so many requests, we could arrange some of the accommodation or some of the rooms in one more guest house, which is there with us at Connaught Place, Gomti guest house. Yes. See, what you have told, you very simply put it forward like, we didn't do anything, but let me tell you, let me complete. You told me,
see, because I don't know.
Let me complete. See, you told about the negative part. Okay, fine, we have a limitation. We can't arrange an accommodation for such a big program which spans nearly 14 days, isn't it? To be, very practical, 14 days arranging for accommodation for so many participants is a very difficult task. But let me tell you the positive part also. Professor Vidyarthi, he was very clear that whatever accommodation, limited accommodation we have got in this Aravali guest house, will reserve it, one for obviously resource person, because he is the most important person for us right now. And along with that, all the women participants or the female participants who come from outside. So we just made sure, and I believe there are some people who are living in the guest house. So we, with our limited resources, we tried to do whatever best we could. But okay, yeah, even if we come up with a dormitory kind of a thing or a hostel kind of a thing, okay, it will be very good and we welcome that.
I try to. If you have something more to say, you can add it to this.
Anything? Anyone? Jamia?
I would like to thank Professor Jemal for your wonderful workshop, wonderful presentation, and I can't believe a person having expert in their field, having so down to earth nature. And we take a lot of inspiration from sir, your dedication, your hard work, your inspiration, and this is inspiration for us. And sir, I would like to thank Professor Vidyarthi sir and Professor Jahi sir for arranging this wonderful workshop. And I also request him to conduct these types of workshop in the future. Thanks. Thank you so much.
Every year we conduct not this GIAN workshop, but let's say another 2 days research workshop every year. So that we'll keep on doing.
I also come every day.
Every year. Anything else that would like to? Otherwise, we can start with.
Hello sir. I attended many workshops even in IIT Delhi, IIT Roorkee and IIT Abawajy. But this was one of the wonderful workshops. I had many doubts before coming here regarding the cloud computing. But I asked many questions to you. But most probably you have cleared all the doubts. Thank you sir for the wonderful workshop. And thank you to Vidyarthi sir for conducting such type of wonderful workshop.
Would you like to say something?
The microphone.
You catch hold of Professor Jemal since I don't know how many days. Got hold of him.
Actually, I think Prof. Dr. Jemal, and he gave us a lot of information. I stay with him 20 days. 10 days in Mysore, and also here I think 12 days, and also there is 3 days extra. I thank him a lot. He gave us a lot of information. He improved my skills in everything. So I thank him a lot. And also I thank Professor Bibi and Professor Zahid. Thank you.
I thank you on behalf of Professor Jemal because you shared your laptop.
Yes. Actually, I brought with me purposely, and he's complaining that he told him he can't have place. He told me the same thing. I'm at the airport. I carry this person with me because I have his laptop. I can't take it back to Mysore. How can now? I said, now you coming with me. I brought him. And I said, I need an extra bedroom, extra room. He said, no extra room. So I told him, I'll give you my room. And I'll go and get the hotel myself. Come. So that's what we did, actually. Until we came here, the arrangement was that he will take my room, and I'll go and get a hotel room, and then everything will finish. So what I'm trying to say is that you will face a lot of problems. There is 2 things you can do. You can find a solution and try your best this thing never happen again, or make a lot of noise. So my personal approach is always see the solution. Why? Because there is always hotel, right? Why should I argue with him? The easy way is, okay, 1 room is available. I have a guest. I am his guest. So the enemy of it, my enemy is my friend. So I just put him in my room. I'll go get a hotel. Problem solved.
Yeah.
So that's what my personal approach is. Always I do things like this. Is there a solution? I will do a solution. Is no solution? Leave the whole thing. Okay.
So, anyone else? No.
I have something. I have some small gifts about Australia for Professor Deakin.
Thanks a lot.
And for Professor Jemal.
Rather, we can have a photograph. This way. You can put one hand here, one there.
It's Australian kangaroo.
Okay?
Thank you.
Thanks a lot. So we can start with thanking Professor Jemal, because last 10 days he spent with us, and with such a, even last 2 days he is not keeping well also, and he never let us felt that he is not well. You see that whenever I asked, are you okay sir, he said, I'm full of energy. So that kind of let's say spirit one should have. And as I told you that in spite of his laptop not working, he prepared slide every night and presented us as if nothing has happened. So that is really wonderful, sir. Even we have to learn a lot from that. Really, that was a commendable. As far as this one is concerned, I just had a joke in my mind just when this facial expression. So you see that face recognition. Na? Nowadays, many mobiles, they are having the lock, as the face that opens on the facial expression. Like you have thumb impression, biometric. So the facial expression is there. So one fine morning, a lady was putting just at 5:30 or so, putting lipstick, powder, etc., etc. So the husband asked, "What happened? 5:30 you are putting all these things." Then he said, "Oh, my mobile is not opening. The problem is mobile is not opening." So see that these kind of things happens with the technology, and one has to adjust this. So anyway, thanks a lot, Professor Jemal. Thanks a lot all the participants who, many of them, even I regularly see the faces of them, and they are happy to have you here in this particular workshop. Such a vigorous, let's say, enthusiasm that they have in attending this kind of event. Many our friends are from Tamil Nadu also, from Karnataka also, so that I can feel, I mean, the type of effort that you have put behind attending this particular workshop. So thanks a lot. Thank you very much. What we could do, we have done. What we could not do, we are sorry for that. But the problem was, as Dr. Zahid explained, we got only 3 rooms in our guest house. That too, when Professor Jemal said, I need one more room, we were puzzled that how to manage this particular one. But then unfortunately, some of the ladies did not turn up. Right, we thought of first accommodating the ladies in our guest house. Eventually we got Gomti guest house, which is little far. We managed in that also, but then eventually what happened that many of you did not accept it, that we need to stay at the Gomti guest house, which is at Connaught Place. Rather, if you could have stayed, you would have enjoyed, because it is in the heart of the Delhi city. Anyway, what we could do, I'm thankful to you that you have accepted. What we could not do, we'll try to improve, as Professor Jemal said. Eventually, we'll be looking at that how we can manage these things. So that this particular event is coming to an end after 10 days, let's say. I think that we all must thank Professor Jemal for being with us for last 10 days. So I would request my senior most professor of the school, Professor S. Balasundaram, to come at and present let's say a token, a gift from this particular program to Professor Jemal. So please, and happy for you can present. You don't know who is giving who. Now I would request Professor Jemal to please come at the dais and distribute the certificate of participation to this workshop to each and every individual.
राजपूत के नाम में लिखते हो आधार कार्ड के साथ में अरे ये तो ऐसे कार्ड भी है फोटो कार्ड भी है मतलब क्या है ये इससे सारा काम हो जाता है सामान देने का मटेरियल है वो अंदर ही पड़ा है उसको ले लेंगे
Although Professor Vidyarthi has already thanked Professor Jemal, but I would also like to thank him on my own personal behalf and on behalf of the entire school. We have to learn so many things from him. He is so full of energy, he has so much in-depth knowledge of the subject, and he is always open to whatever you want to ask him. I have never seen any person who is so willing to mingle with the participants, encouraging them to come up with the problems, even helping them in problem formulation, whatever research they are doing. So indeed, we have to learn so many things from you, sir. So and thank you so much, for spending time for all of us, for delivering all these lectures. And we do hope that you keep coming. Before starting the certificate distribution, I would like to thank, I actually like to give special thanks to all the volunteers who have really run around to make this event a possibility and to make that everything works smoothly over here, other than accommodation. So,
I want to say something. That I don't know why, I will not say like this, but I said this not as negative.
Yeah.
Because when I give feedback, usually even in my country for government or anything, usually I don't give, okay, it was good like this, I say, but we have to give to improve,
Yes,
what to improve.
Otherwise,
otherwise, if I don't know that it will be very good, I would not come from very far, even I don't get hostel, but I came and on my own, they will not give me anything. That I came from very far because I know it will be very good. Means I said this only means it was very good and everything perfect except this. Means only to improve.
We really appreciate that you spared time for us for this program.
Feedbacks are meant for that only, for improvement only. What else for feedback?
Yeah, that's what I said. Means it was good.
So it is not that he is also telling the problem that we had. Take it positive, we are also taking it positive.
They take it in positive, you take it positive. So actually you gave a very good feedback.
Let's come up with one more
true feedback.
Yeah, before starting the certificate distribution, I would like to introduce my volunteers who have been running around. So, Krishnveer, Amardeep, and our technological support, Chandresh ji. You have been seeing, but today I guess he is busy with his cricket assignments. I think so. So I'll start the names. Those participants can come over the stage to collect their certificates from sir. Let us start with Mitchell Kaushik.
You can go print. Yes, okay. So you are taking
Amardeep Singh. Mr. Bilal Abdullah, Hezam Murshid.
They are closer. Closer to the dice.
Okay, Mr. Krishan Dutt. Mr. Krishnveer Singh. Mohammad Muzakkir Hussain. Mohammad Muzakkir Hussain. Okay. And then Mr. Mohit Kumar from IIT Roorkee. We have two Mohits here. He is not here. Okay. Mohit Kumar from iNurture Bangalore. Nithya B, NIT Trichy. Mr. Pramod Kumar Siddhartha, Jamia Millia Islami. Rathina Raja Jairaj. Mr. Ravindra Kumar Singh Rajput. Mr. Sumit Kumar. Dr. Karan Singh.
Did you take photo?
Mr. Mangala Prasad Mishra. Mr. Mustafa Najmi. Mr. Natasha Baby.
7412.
Dr. Ratneshwar. Shahadat will have to collect his certificate. Mr. Sayyid Arshad Ali. Mr. Ashish Shekhar. Mr. Gaurav Sharma. Mr. S.R. Chaudhary. Ms. Pooja Tiwari. Mr. Mohammad Tajammul. We should follow ladies first. He was really excited to come to this. Mr. Bakar Ahmed. Mr. Anshul Khairwa. Mr. G. Kingsley Jiva Ashish. Ms. Damini Seni. Ms. Damini Seni. Ms. Megha Sundaria.
Okay.
Dr. Jitendra Kumar Babu. Ms. Rahat Yazdani. Rahat Yazdani. Mr. Mohammad Tausif Alam. Mr. Ashok Kumar Mandal.
नहीं देखो प्रमोद के लिए ये देखो
मिस्टर महेंद्र कुमार जानी
दूसरे के कैमरे से खींचो तो कई बार वैसे भी हो जाता है नहीं वो दूसरा देखो थोड़ा भारी शरीर है कितना वेट
Mr. Pardeep Singh.
पर्सनल है ना उनको ग्रुप में मत डालना उनको एक एक करके भेजना जो जिसके है उसको भेजना पर्सनल ग्रुप में
Thank you so much for your participation and Haiti is waiting for
तुम्हारा देखता हूँ नहीं वो बड़ा जवान कौन बोला हम बोले
No.
No, working. Okay. I think it has come. You know, everything has a beginning, but also has an end. So this is not an end for us. I have challenged you, and I also promised, as long as, remember we talked about underloading and overloading. So as long as we keep me in underloading state, I promised to work with you. So this is the beginning of knowing each other, working. So I am not looking at you as younger of me. I'm looking at you as my colleagues. So when I say working with you, that's what I mean. I'm not working for you, or you are not working for me, working with you. So I put the challenge out for you there, and it is your opportunity to take. I normally don't put out challenges, and I normally don't take a lot of people to work with. Very selective. So here is, again, I keep that challenge, I keep that promise, and let's see if you want to continue with what we have done here. Now, let's pass that. The second stage is that I actually came here because of these two professors. And I would like to appreciate them personally, even though I've been coming here for something 7 years, and I know them very well as far as I know myself, but I still find them new every time I come here. Find them more energetic than the last year. And so I think this momentum will keep on, at least from my part. And I thank them for bringing me back to Delhi again. And last but not least, I want to really say thank you to those who have tried to fix my laptop, even though sometimes I was actually very, very tired. I still keep going with them to Naru Place. I get to know what Naru Place looks like. I get to see, people asking me to buy a pirated software for 10 rupiah. and so I learned a lot of things. And recently I also learned how to bargain, particularly from Karnataka guys. They told me if they say 50, say 10. So, you see, I did learn something in return. I did learn how to take auto. I did learn that auto driver is speed. But taxi also drivers do that. And last night we took a taxi And this guy got off and bought something. I didn't know what he bought. And then he put it in his mouth. And every few minutes he stops the car, opens the door. And I said, this is good because the auto doesn't speed down, it speeds up. And all came on my glass, on my face. And so I learned all this because, see, what this says is that if you really need to know the people of this area, you need to actually be with the people. You need to take the speeds. You need to take the hunger. You need to eat the spicy food, even though tomorrow when you try to go to the bathroom, it's another story. But you need to learn all these things. That you understand is something you can't buy, something that you experience. You don't actually come to some place and live as a king and go as a king. It is you actually immerse yourself. That's what I have tried to do. I have immersed in myself, found everything. Even though I present it as a job, for me, it was a big learning, a big something that I can't get it. India is not new to me. When I was young, he knows that most of our classes were taught by Indians. Indians who lived and fought. You don't believe that in my country we have Indians during World War II who came and fought and lived there. Teacher is living there, Indian. So there is a link between us. There is a big burial place of Indians. The First World War, Second World War, I don't remember. The British brought them. There's a big community in there. So there is a connection between me and Indian. I don't know, maybe someday I'll claim that I'm from Tamil Nadu because I look like them. I really wanted to see. I grew up with watching Indian movies, and when I see Shahadat, getting very angry, I want to experience someone to show me. I asked them, where is that movie things I see, that what's it called?
Saathi Mere Saathi.
Saathi Mere Saathi movies that I grew up with. The Chan music that I listened to. Mere Saathi, all. Where is that place? I want to see that India, that Delhi that they show us there. I didn't see. Is that a fake? And just showing me some things, or I want to experience. My Shahadat gets angry every time I want to go out. Because I want to see, come to Delhi and they can experience that. The reason I'm bringing Shahadat here is that he was actually protecting me. That's what I'm trying to tell you. He wants to make sure that I have enough sleep. He wants to make sure that he has put in his questions to me, get his answers. So I understand it. I want to learn from him, but he's not going to teach me. Why? Because he's actually saying safely. I'm actually saying to him, let's do this. He doesn't want to do that. I want to learn from him, but I learn a lot of things from him. So there is also another person who comes every morning. It's not my mistake to come late. It is Vlad's mistake. Okay? It takes me about 40 minutes to wake him up. And you've seen the experience. Sometimes I leave him and go. So I really appreciate that one also. Because my first day, I adventured. I said, I will go where the class is, my second day, by myself. Because I'm coming here, I actually know there is a field down there. I go every morning before I come here. What you don't know is that I go every morning before I come here, go there, walk for half an hour, just talk in the field to myself. Today what I'm going to do, relax and take all this in. and come and shower and then wake up my friend Bilal. And I do this every morning. At least walk for 15 minutes, 20 minutes, half an hour sometimes. So that gave me a little bit strength. And then there are other people also, so that actually took me to a nice restaurant. Very nice food, beautiful, that I haven't seen in India. This is my first time to experience such kind of food. So I saw many things that many Indians didn't get a chance to see. I'm saying this because I'm talking as a privileged person to get to explore all kinds of sections of societies, religions, which I respect all as a person. I look at this as a person. I don't look at who you are, whether you are a woman, a man, a girl. I don't see that. I don't have that vision. Or you have different religion. I don't see that as a vision also. I see a human being that I deal with. So I enjoyed all those, and I thank you for making my stay very good, very enjoyable, very educational to me also. If all those elements were not here, you know, the support I got from these guys, the questions that I received from them to come, the smiles that come from the girls, particularly from Tamil Nadu, all these, you know, the happy, the Hakims, the Mustafas, all these actually made my day. And today also, I got a very nice surprise when somebody said to me, I reserved you time, but we were actually working on demand basis. It was actually not on demand, on spot instances. So that was also very interesting, because I actually consider all my students, even back in Australia, as just another friend. I work with them as another friend. Okay? So now I came here with two friends, Professor BP and Professor Shai. But now I have many friends. So this is because of them, and I thank you them again. Thank you, and hopefully you actually gain something and you can benefit from this. And someday, okay, when you become either a prime minister or a minister, don't forget me, okay? Don't forget to give me some 50 lakhs. All right? So thank you very much.